Hello friends, welcome to online lecture series of discrete mathematics. Today we will start with our next chapter, that is graph. So graph, what is graph? So generally graph consists of two things. First is the vertex and second one is the edge. So what are these vertices, what are these edges? So set V, right? Generally whatever vertex, generally vertex is denoted by this V and set by this E, set of edge by this E. So set V is equal to V of G, whose elements are called the vertices, points or nodes. By set E, it is equal to E of G, that is set of edges of an unordered pair of distinct vertices called edges of a G. Generally, we denote the graph by this G in bracket V comma E. The meaning is V is a set of vertices and E is a set of edges. So vertices U and V are said to be adjacent if there is an edge E is equal to U comma V. So the vertices, two vertices are said to be adjacent when there is an edge. There is an edge, that is U comma V. So this vertex U and this another vertex V. So this is adjacent. U and V are adjacent, or you can say neighboring vertices. So there is the edge E between these two vertices. So this U and V are the adjacent to each other. Next, degree of vertex. What is the degree of vertex? A degree of vertex is the number of edges incident on a vertex. What? A degree of vertex is the number of edges incident on that vertex. Here, self loop is counted twice. Generally, the degree of vertex is denoted by the symbol D of V. So number of edges incident on that vertex means number of edges associated with that vertex. We can say this is a degree of that vertex. So see here, so this vertex A, right? So number of edges associated with this vertex. This is 1, this one is 2, and this one is 3. So these 3 edges, 1, 2, and 3. These 3 edges are associated with this A. So degree of A is 3. Degree of A is 3. Degree of D. Degree of D. Number of edges associated 1. This is 1 and this one is 2. So degree of D is 2. Degree of B. Degree of B. So degree of B. Here self loop counted twice. So here the self loop is here. Right? So what do you mean self loop? Self loop is what? Whatever age whose first starting and ending point are the same of that age, right? So adjacent vertices, right? Adjacent vertices are the same vertex. There is B here, right? So self loop, right? This is a self loop, right? So age starting with B and end with B, right? So here this self loop counted, so this is 2 and number of edges another associated with this B is 1, 2 and 3. So 3 plus 2, that is 5. So degree of B is 5. Then degree of C, 2 edges, 1 and 2 edges associated with this C. So degree of C is only 2. So this is the degree of the vertex. This is the degree of the vertex. Next, path. A path of length n is a sequence of n plus 1 vertices of a graph in which each pair of vertices is an edge of the graph. So what is a simple path? Simple path. So a path is called a simple one if no edge is repeated in the path. No edge is repeated in the path. Means you have to travel from one vertex to another vertex through a different path. That is, all the vertices are distinct except first vertex is equal to the last vertex. Elementary path. The path is called elementary one if no vertex is repeated in the path. That is, all vertices are distinct. All vertices are distinct. Circuit or a closed path. Circuit or a closed path is the path in which start and ends at the same vertex. That is, V0 is equal to Vn. Simple circuit path. A simple circuit is a simple path which is a circuit. So we'll see what is using this a figure or using this diagram to find out the simple path. So here, simple path from V1 to V6. This V1 and V6. Simple path is V1, V2, V5, V4. So simple. What is it? What do we mean by simple path? See the definition. A path is called a simple one. No edge is repeated in the path. That is, all the vertices are distinct. So here, no edge is repeated in the path. So we can this so V1 to simple path. V1 to V6. So V1, V2, V3, V4, V5 and V6. So we travel from the different so no edge is repeated. This is V1 to V1 is one edge, V2 to V3, V3 to V4, V4 to V5 and V5 to V6. Simple path. Elementary path from V1 to V6. No vertex is repeated. This is V1, V2, V3, right? V5, V4 and V6. Is no simple path which is not elementary from V1 to V6. That is V1, V2, V3, V5, V2, V4 and V6. A path which is not simple, right? Starting from V2. So V2, V2, V3, V4, V5, V3, V4, V6. So simple circuit. Circuit there is the first and last vertex. Starting from V1, V2, V4, V6, V5, V3 and V1. So these are the number of definitions of this simple path, elementary path, right? So circuit or closed path and a simple circuit path. The next, pendant vertex. What do you mean by the pendant? The vertex with degree 1 is called as a pendant vertex. Vertex with degree. We know the degree. Degree, number of edges associated with this vertex. So, as per definition, a vertex with degree 1 is called as a pendant vertex. So, find out the vertex whose degree 1. So, here, V1 2, V2 2, V3 3, V4 2, and here V5. The only one edge is associated with V5. So, V5 is your pendant vertex. Pendant edge, the only edge which is an incident with pendant vertex is called as a pendant edge. So this E5 is your pendant edge. Old vertex, a vertex having the degree odd. So not old, that is odd vertex. A vertex having degree odd is called an odd vertex. So here degree odd vertex, right? So V1 degree is even, V2 is even, here V3, 1, 2, 3. This is a odd degree vertex. A vertex having degree odd. Also V5 whose degree is odd is 1. So this V3 and V5 are the odd vertex. Even vertex for even degree is, right, whose degree is even. So here V1 whose degree is 2, V2 is 2, again V4 is 2. So V1, V2 and V4. These three vertices are the even degree vertex. Incident edge. And edge is called as incident with the vertex is connects. Adjacent vertices, two vertices are called adjacent if an edge links them. There is an edge u comma v, then we can say that vertex u is adjacent to vertex v and vertex v is adjacent to vertex u. So here these two v1 and v2 are adjacent to each other because these are connected with by an edge e1. Same v1 and v3 is also adjacent, but these two vertices are connected by an edge e3. Same v3 and v2 also and adjacent vertices, right? So that is a two vertices adjacent if edge link them. So we have already find out the pendant vertices, that is v5, pendant edges, that is e5, or vertices, that is v3 and v5, even vertices v1, v2 and v4. Right? So adjacent vertices is even edge incident is a question. The incident edges. So incident edges are edge e1 is incident on v1 and v2. Edge e2 is incident on v1 and v3. Edge e3 is incident on v2 and v3. Edge e4 is incident on v3 and v4. Edge e5 is incident on v5 and v4. Then adjacent. The vertex v1 is adjacent to v2 and v3. Same vertex v2, this v2, it's adjacent to this v1 and v3. Same the vertex v3 is adjacent to three vertices, that is v1, v2 and v4. Then v4 also adjacent to v3 and v5. v5 is adjacent to v4. Cut points or cut vertices. Cut points or cut vertices. Consider a graph g comma v. A cut point for a graph g is a vertex v such that g minus v has more connected components than g or disconnected. A subgraph g minus v is obtained by deleting the vertex v from g and also deleting the entire edges incident on v. So cut points means what, or cut vertices means what? After deleting that vertex, right? After deleting that vertex, so we have to delete whatever edges associated with that vertex. These are the cut points or the cut vertices. So consider the graph, right? Example g minus v1. So whenever we delete this, whenever we delete this v1, right? So we have to delete this edge, and this edge also. So your graph will be just simple like this. So this is a graph after deleting the edge v, sorry, vertex v1. Same g minus v, that is g minus v3. So after deleting v3, this v3. So these three edges, this one, and this one. So this is only a graph. Right? Same G minus V5. So V5, so you have to delete all these edges. All these edges associated with this V5. So we'll stop here. In next session, we will see the next point.